Doctors very rarely know the exact dosage that a medical facility might have on hand, but they still need to prescribe a certain weight, or mass, of medication to their patients. Therefore, it will be a common practice for nurses to convert a prescribed mass of medication to the correct amount, based on the medicine available on hand. Though it may sound difficult, this process is one that you may already have practice doing. For example, if you need 200 milligrams of headache reliever, and the bottle states that each tablet contains 100 milligrams, it is very simple to come to the conclusion that you need 2 tablets to reach 200 milligrams. This example, however, is extremely simplified. In this video, we will be introduced to a mathematical equation that can help us calculate the correct dose to give to a patient based on a supply dosage. This brings us to an interesting question. What is the difference between a dose and a supply dosage? One dose of medication is the amount of medication you give to a patient as ordered by the doctor. When we work through these problems, most often we are given a dose, a weight of medication ordered by the doctor, and we are trying to figure out how many units of medication to give the patient to complete that dose, be it in tablets, capsules, or milliliters. The supply dosage, on the other hand, is the concentration of medication in a given unit indicated by the label of the bottle you have available. We use the supply dosage to inform the number of units we'll give to a patient to fulfill the required dose. The formula we'll use to do so is shown here. D over H times Q equals amount per dose, where D equals the amount of medication desired by the doctor. To easily remember this variable, you can shorten this to D equals desired or D equals doctor. This unit will always be a unit of mass or weight, such as grams or milligrams. H is the mass or weight of medication on hand. You can shorten this to H equals on hand to remember it more easily. This unit will also always be a unit of mass or weight, though it will not always be the same unit that the doctor ordered. The final variable, Q, refers to the quantity of medication a patient would need in order to consume one supply dosage, as prescribed by the label. This unit can be one of two things. If you're talking about tablets or capsules, the unit will be in tablets or capsules. If the medication is a liquid suspension, the unit for Q will be a volume, usually milliliters. Most students find D the easiest variable to understand, but many struggle conceptually with the idea of H and Q, so let's do some practice identifying these variables. Here we have a bottle of medication A. As we can see, the label says that each tablet contains 500 milligrams of medication A. Let's identify H and Q from this information, beginning with H. H is the mass or weight of the medication we have on hand. On the label, we have 3 pieces of information: the name of the medication, the mass of the medication, and the number of tablets needed to complete one supply dosage of the medication. Since H is always a unit of mass, that means that H in this case is 500 milligrams. Be careful. It is a common mistake to include more numbers and units than are called for here. Each variable is equivalent to one number and one unit, and no more. Now, let's identify Q. Q is the quantity needed for the supply dosage. Since we have already identified the supply dosage as 500 milligrams, now we need to figure out what we would need to consume in order to complete the supply dosage. Here on the label, we are told that the medication is in tablet form, and each singular tablet contains the supply dosage, 500 milligrams. That means that the quantity that a person would need to consume in order to consume 500 milligrams of medication A is 1 tablet. Now that we know how to identify the 3 variables of our equation, let's take a look at the process of calculating dosage. The process itself has 4 steps. First, we need to identify the variables D, H, and Q. Next, we need to convert D and H to the same unit. Third, we need to estimate the correct answer. This is a step often skipped by many students, but utilizing it may mean the difference between a correct calculation and a harmed patient. Finally, we'll use the formula to calculate the amount of medication given to the patient at each dose. There are 2 primary ways in which we will utilize this process, and the method you use is dependent on the form of medication used. Medication can come in 2 forms, liquids and solids. Today, we'll start with the solids, capsules and tablets. Let's do an example. Say the doctor orders 100 milligrams of medication B. You have a bottle with 50 milligrams per tablet on hand. How many tablets should you give the patient? We start with step 1. Identify D, H, and Q. D is the amount of medication ordered by the doctor, and we can see that the number and unit are clearly told to us here in the question. The doctor orders 100 milligrams, so D equals 100 milligrams. H is the mass of the medication on hand. We can find this information by finding keywords such as on hand or the label says. Here we can see that the bottle on hand contains 50 milligram tablets of medication B. Since this variable is always a number and a unit of mass, our H is equal to 50 milligrams, or the supply dosage. Q is the quantity of medication for the supply dosage. A good trick for finding this information is to look for the word per, or a grammatical equivalent. Anytime you see a mass per a number of tablets or a volume when we work with liquid suspensions, Q follows the word per. Here we can see that the medication on hand is 50 milligrams per tablet. So Q equals 1 tablet. The next step is to convert D and H to the same unit. But here we can see that they're both already in milligrams, so no conversion is needed. Step number 3 is to estimate. If we're supposed to give 100 milligrams and have 50 per tablet on hand, 50 is half of 100, so we should be giving 2 tablets to the patient. Finally, we calculate D over H times Q, remembering our estimate. If our number comes out far from that estimate, it's a good indication that we need to rethink our estimate and our math. If we estimated correctly, this should come out to around 2 tablets. First, we substitute our variables. D is 100 milligrams, H is 50 milligrams, and Q is 1 tablet. Because we have milligrams in the numerator and denominator here, we can cancel the unit. We are left with 100 over 50, which we can reduce to 2 times 1 tablet, which leaves us with 2 tablets per dose. That matches our estimate, so we can be confident that it is correct. You won't always be dealing with capsules or tablets, though. In many cases, the medicine you'll need to administer will come in a liquid suspension, which means that the powdered medication has been stirred into a liquid and packaged for consumption. This means that all of our quantities will now be in volumetric units, such as milliliters, so finding Q might be a bit trickier. Let's look at an example of a bottle of liquid medication and find H and Q for practice. H is still the mass of medication that we have on hand, and on this label we can see that the liquid suspension of medication C has 50 milligrams in every 2.5 milliliters of liquid. So our H here is 50 milligrams. Q is a little different. Remember, it's the quantity or volume of medication needed to consume the supply dosage. Here we can see that the label says 50 milligrams per 2.5 milliliters. Milliliters is a volume, so 2.5 milliliters is our Q. Let's do an example with a liquid suspension. The doctor orders 65 hundredths of a gram of medication D orally every 4 hours. You have a bottle on hand with a liquid suspension of 325 milligrams for every 5 milliliters. Our objective here is to find out how many milliliters we give the patient at each dose. So let's start with step 1 and identify our variables. D is how much the doctor orders, and we can see here that they order 65 hundredths of a gram for this patient, so we can substitute that in for D. Next is H, the dosage on hand, and we can see that the bottle on hand has 325 milligrams per 5 milliliters. Since H is just a number and a unit of mass, our H is going to be 325 milligrams. Finally, Q, the quantity of medicine that a person would need to consume in order to ingest 325 milligrams of medication. Here in the question, we are told that 325 milligrams of medicine is present in every 5 milliliters of liquid suspension, so our Q is 5 milliliters. Our next step is to convert D and H to the same unit. In this example, D and H are written in different units. D is in grams and H in milligrams, so we need to convert one of these so the units match. Generally, it's easier to convert larger units to smaller units, so you aren't dealing with decimals. So let's convert grams to milligrams. First, we need our equivalent, which is that 1 gram is equal to 1,000 milligrams. When multiplying with multiples of 10, you can move the decimal to the right the same number of times as there are zeros. So here, we'll multiply and move the decimal 3 times to the right, leaving us with 650 milligrams. You could also convert using dimensional analysis or a conversion slider if that's more comfortable for you. I like to replace my variable at this time with the new number and unit, so there's no confusion moving forward. Moving on to the next step. Let's estimate what our answer should be. If the doctor ordered 650 milligrams and the bottle on hand has a supply dosage of 325 milligrams, which is half of 650, then it makes sense that we should give twice the supply dosage. Since the supply dosage is present in 5 milliliters of liquid, that means we'll be giving 10 milliliters to the patient. Now let's do our math, remembering our estimate so we can check our work. We substitute in our equivalents first, and we're left with 650 milligrams over 325 milligrams times 5 milliliters. We can cancel the milligrams units here since they're present in the numerator and denominator, and that leaves us with 650 over 325, which we can reduce to 2 times 5 milliliters, which does equal our estimate of 10 milliliters per dose. I do want to take a second and look back through the question to illustrate an important point, specifically regarding this piece of information. The question tells us that this dose should be given every 4 hours. You'll see information like this added to problems you'll see in your study, but it won't always be relevant. In this problem, for example, the number of times a day a patient receives a dose is irrelevant to the question we're being asked, which is only how much the patient receives at each dose. That amount remains constant and is not affected by the number of times a patient receives a dose. There are, however, other types of questions you may encounter that will ask you to use that information, and we'll be going over those types of questions in another video.